Why does fire burn? It sounds like the kind of question a child asks before we gently steer them towards something more practical. We assume the answer is so obvious that the question itself must be naive. Fire burns because it's hot, because that's what fire does. And in everyday life, that answer works well enough to keep us from touching the stove. But if you slow down for even a moment, you realize that nothing has actually been explained. We've just swapped one familiar word for another and agreed to stop thinking. Richard Feynman had little patience for that kind of stopping point. Not because he enjoyed complexity for its own sake, but because he understood how easily we confuse understanding with recognition. The moment we hear an answer that sounds familiar, our curiosity shuts down. We feel satisfied not because we know, but because we recognize the language. And that psychological trick is one of the biggest obstacles to real understanding. The power of this question lies precisely in its simplicity. It doesn't sound technical. It doesn't require equations. It doesn't announce itself as philosophy or physics. And that's why it's dangerous. Because it exposes how shallow many of our explanations really are. When you ask why fire burns, you're not just asking about fire, you're asking how explanations work, where they end, and why we accept them when we do. Feynman often pointed out that explanations are always relative to what the listener already understands. If you explain fire in terms of atoms, you're assuming the person already knows what atoms are. If you explain atoms in terms of energy, you're assuming an understanding of energy. Keep pushing why, and eventually you reach a layer where the explanation can't be translated into everyday intuition anymore. Not because science has failed, but because language has reached its limit. And this is where people often get uncomfortable. We want the universe to meet us halfway. We want answers that feel like common sense. But common sense is not a measure of truth. It's a measure of familiarity. Fire doesn't care how long humans have been afraid of it. The underlying processes were happening long before there were nervous systems to interpret them. Psychologically, this is unsettling because it means our confidence is often misplaced. We walk around feeling as though the world is well understood, when in reality we've just agreed on convenient stopping points. We know enough to function, so we mistake that for knowing what's actually going on. The question, why does fire burn, quietly pulls that illusion apart. Philosophically, the question does something even more radical. It reveals that understanding is not a destination but a process. There is no final answer waiting at the bottom. There are layers, each one coherent, each one incomplete, each one depending on assumptions you didn't realize you were making. Fire becomes a doorway, not a topic. Feynman's brilliance was never about having the last word. It was about knowing where not to stop. He showed that the most ordinary questions, if taken seriously, lead to the deepest insights, not just about nature, but about the limits of human thought. So when you ask why fire burns, and the answer refuses to stay simple, that's not a failure of explanation. It's the first honest signal that you're finally asking the right kind of question. Once you stop mistaking familiarity for understanding, the next assumption to collapse is the idea that fire destroys things. That belief feels almost instinctive. We watch wood turn to ash, paper curl into smoke, entire structures disappear, and the word destruction feels unavoidable. But here again, the feeling is misleading. Fire does not eliminate matter, it reorganizes it. And that distinction, subtle as it sounds, quietly reshapes how you see the world. When something burns, nothing vanishes. The atoms that made up the wood, the paper, or the fuel do not cease to exist. They change partners. Carbon atoms that once formed long, stable chains in solid material eagerly combine with oxygen from the air. Hydrogen joins oxygen to form water vapor. Nitrogen drifts away largely unchanged. What looks like an ending is really a redistribution. Feynman loved this point because it exposes how human language smuggles in false assumptions. Words like consumed and destroyed reflect how an event feels to us, not what actually happens. From the universe's point of view, burning is not dramatic at all. It's simply a faster route to a more stable arrangement of atoms. The energy released in a fire is often described as being created by the flame, but that's another illusion. That energy was already there, locked into chemical bonds long before the match was struck. Fire doesn't invent energy, it reveals it. It's the visible moment when stored energy is allowed to escape because a more comfortable configuration has been found. This reframing forces an uncomfortable psychological realization. Much of what we call loss is not disappearance, but change. The house that burns down feels gone forever, yet its atoms are now in the air, the soil, the walls of other buildings, the lungs of nearby trees. The universe keeps perfect accounts even when our personal ones are wiped clean. Feynman wasn't trying to minimize tragedy or emotional impact. He was pointing out that nature operates under rules that don't care about human narratives. Fire doesn't erase history, it rearranges it. The finality we feel is a product of perspective, not physics. Philosophically, this challenges our attachment to permanence. We experience objects as stable and enduring, so we assume they are. Fire brutally corrects that assumption. It exposes the fact that stability is conditional. Matter holds its shape only as long as the surrounding environment allows it to. Change the conditions and the structure gives way. And notice something important. Fire is not an exception. It's an example. The same principle applies everywhere. Rust is slow burning. Metabolism is controlled burning. Even the energy powering your thoughts comes from chemical rearrangements similar in kind, though gentler in speed. Fire merely makes the process impossible to ignore. Once you see burning as transformation rather than destruction, the flame takes on a different character. It's no longer a force that annihilates, it's a process that exposes how temporary all arrangements are. The fear remains, and rightly so, but it's joined by insight. Feynman believed that understanding. Nature doesn't make it cold, it makes it honest. Fire shows us a universe where nothing is was. Ted, nothing is erased. And everything is in motion, even when it looks still. And if that unsettles you, it should, because it means what we call destruction is often just change happening faster than we're emotionally prepared to accept. Once you accept that burning is not destruction but transformation, the next illusion to dissolve is the idea that heat itself is a thing. We talk about heat as if it were a substance, something fire has and transfers into us. But that way of thinking, while convenient, is completely wrong. And Feynman would insist we let it go because it blocks a far more interesting truth. Heat is not a material. It doesn't flow like water or accumulate like dust. Heat is motion. More precisely, it's a measure of how violently atoms and molecules are moving. When something is hot, its particles are vibrating, colliding, and jostling with greater energy. When it's cold, they're doing the same thing, just more slowly. So when you bring your hand near a flame, nothing mysterious enters your skin. No invisible hotness crosses the boundary. What happens is simpler and stranger. The atoms in the air near the flame are already moving rapidly because of chemical reactions. Those atoms collide with the atoms in your skin and transfer some of their motion. Your skin atoms begin vibrating faster than the delicate structures in your cells can tolerate. Proteins start to lose their shape. Nerve endings fire signals. Your brain interprets that sudden chaos as pi. And here's the crucial point. The pain is not a property of fire. It's not even a property of heat. It's a biological interpretation. The universe is not announcing danger. Your nervous system is. Feynman found this fascinating because it exposes how deeply indirect our experience of reality is. We don't feel atoms moving. We feel meaning layered on top of motion. Evolution didn't design us to sense the truth. It designed us to survive. Heat feels urgent and threatening because organisms that didn't treat it that way didn't last long. Psychologically, this creates a powerful illusion. Fire feels aggressive. Heat feels like an attack. But physics describes something utterly indifferent. Particles obeying simple laws, transferring energy, because that's what motion does. There is no intent, no hostility, just interaction. This gap between experience and mechanism is where confusion thrives. We trust sensations because they feel immediate and undeniable. But immediacy is not accuracy. The faster atoms move, the more damage they can cause to biological structures, and the more urgently your brain reacts. That urgency feels fundamental, but it isn't. Philosophically, this should unsettle you, because it means one of your most vivid sensations, burning pain, is not a basic feature of the universe. It emerges from the interaction between blind physical processes and fragile biological systems. The laws of physics don't include suffering. Suffering appears only when those laws meet life. And yet, this doesn't diminish the experience. It elevates it. Out of simple rules governing motion arises something as rich and urgent as sensation. Out of meaningless collisions comes meaning. Fire doesn't know it's hot, but you do. That difference is extraordinary. Feynman never suggested that understanding heat should make you careless. Knowing that heat is motion doesn't protect your hand from a flame, but it does change how you think. You stop seeing heat as a thing that attacks you and start seeing it as energy redistributed in a way your body cannot tolerate. Once you grasp that heat is motion, the flame loses its personality. It becomes a region of intense activity, not a malicious force. Your reaction remains the same. You pull away, but now it's guided by insight rather than myth. And that shift matters, because it reminds you that what feels fundamental often isn't. The universe doesn't burn you. It moves, and your biology decides what that motion means. Once you understand that heat is motion rather than a substance, the next realization follows almost inevitably. Fire itself is not an object. We speak about it as though it were a thing you could isolate, capture, or possess. But fire has no independent existence. It is not matter. It is not energy sitting still. Fire is a process, a brief, visible event that occurs when conditions are just right. This idea runs directly against how our minds prefer to work. We like nouns. We like solid objects with clear boundaries. A chair exists whether or not you're looking at it. A rock remains a rock even if nothing happens to it. Fire feels similar because it has shape, color, movement, but that feeling is misleading. Remove the fuel, remove the oxygen, or change the temperature, and the fire doesn't move or resist, it vanishes. Not because it was destroyed, but because there is nothing left for the process to do. Feynman would emphasize that what you see as a flame is energy momentarily made visible. The glowing region is mostly hot gas and light emitted by excited atoms and molecules. Electrons are jumping between energy levels, releasing photons as they settle down. That light is not the fire. It's the announcement that energy is being released. You're watching a transition, not an entity. Psychologically, this is difficult to accept because fire feels alive. It flickers, spreads, consumes. We describe it using verbs, usually reserved for living things. But this sense of agency is something we project. Fire has no intention. It doesn't seek fuel. It doesn't want to spread. It simply continues wherever the conditions allow the reaction to proceed. Change the conditions, and the behavior changes instantly. This perspective reshapes how you think about control. You cannot command fire. You can only influence the environment around it. Limit oxygen and the flame dies. Remove fuel and it disappears. Lower the temperature and the reaction cannot sustain itself. Fire obeys conditions, not commands. And that lesson extends far beyond combustion. Philosophically, recognizing fire as a process rather than a thing forces a broader shift. Much of what we treat as solid and permanent is really conditional and temporary. Waves are not objects, they're patterns in water. Storms are not things, they're organized motion. Even your body is not a static object, but a constantly renewed process, replacing its atoms over time while preserving a recognizable pattern. Fire simply makes this truth obvious. It shows you how something can appear stable and vivid while being nothing more than a sustained event. The flame exists only in the present moment. It has no past and no future of its own. It is continuously being created and destroyed, not in the sense of matter disappearing, but in the sense of the process restarting itself again and again. Feynman loved this way of looking at the world because it strips away unnecessary mysticism without stripping away wonder. In fact, it reveals a deeper elegance. The universe is not a collection of things. It is a network of processes unfolding according to simple rules. Fire is one of the few processes dramatic enough to force us to notice. Once you stop thinking of fire as an object, fear becomes more precise. You no longer fear a malevolent force. You respect a set of conditions that can rapidly damage biological tissue. That respect is grounded in reality, not myth. And when you finally see fire for what it is, energy briefly organized into light and heat, you realize that the flame is not something that exists, it is something that happens. By this point, it should be clear that every step toward understanding fire has taken us farther away from what our senses tell us. And that's not an accident, it's the rule. Your eyes, your skin, your intuition feel authoritative because they are immediate. But immediacy is not accuracy. Feynman understood this deeply, and he returned to it again and again. Your senses are not designed to reveal reality, they're designed to keep you alive. When you look at a flame, you see color and motion. You see something almost hypnotic, something that feels energetic and alive. When you touch it, you feel pain, sharp, urgent, undeniable. It's easy to believe that these sensations are telling you what fire is, but they're not. They're telling you how your nervous system reacts to certain physical conditions. Fire isn't bright because brightness is fundamental. It's bright because your visual system responds to photons in a narrow range of wavelengths. Fire isn't painful because pain is built into the universe. It's painful because rapid molecular motion damages tissue, and your brain evolved to scream when that happens. This distinction matters more than it seems, because once you accept it, you realize that much of what you call reality is interpretation layered on top of physics. Color does not exist at the atomic level. Pain does not exist at the atomic level. Even solidity, the sense that things are rigid and substantial, is mostly an illusion created by electromagnetic forces acting across empty space. Feynman loved pointing out that if you rely on your senses alone, you will misunderstand almost everything important. Atoms don't look like atoms. Time doesn't feel like time behaves. Space doesn't resemble the neat grid your intuition expects. And fire, one of the most ancient and familiar phenomena, turns out to be nothing like it appears. Psychologically, this is unsettling. We want to trust what we feel. We want experience to be the final judge. But fire exposes the limits of that trust. It forces you to admit that your most vivid sensations are survival signals, not explanations. They tell you what to do, not what is happening. Philosophically, this shifts the ground beneath knowledge itself. If perception is not truth, then understanding requires humility. It requires models, experiments, and the willingness to accept explanations that don't feel intuitive. The universe doesn't present itself in human terms. We translate it, sometimes well, sometimes poorly. And yet, this doesn't make human experience meaningless. It makes it contextual. Your fear of fire is real and justified. Your pain response is essential. But mistaking those reactions for insight is where confusion begins. Feynman wasn't dismissing experience. He was rescuing it from false authority. Once you understand this, fire becomes a teacher. It shows you that what feels obvious often isn't fundamental, that what looks simple is layered, that the truth of the world lives beneath sensation, not inside it. And that lesson doesn't apply only to flames. It applies to everything you think you see, feel, and just know. Because the moment you realize your senses report survival, not truth, you begin to see reality with clearer eyes. At this point, it's natural to feel that something familiar has been stripped away. Fire no longer feels mystical in the old sense. It isn't a living force or a cosmic destroyer. It's atoms rearranging, energy redistributing, processes unfolding without intention. And many people hear that and think science has somehow diminished the world. Feynman thought the opposite. He believed this is where wonder finally becomes honest. Because before understanding, mystery is shallow. It survives only because we haven't looked closely. But once you do look, once you follow the question all the way down, you don't lose mystery. You trade it for something deeper. Fire stops being strange because we don't know what it is, and become strange because we do. Think about what you've uncovered. A flame is energy briefly made visible. Heat is motion. Pain is interpretation. Destruction is rearrangement. Perception is translation. None of this is intuitive. None of it feels like common sense. And yet, all of it fits together with astonishing consistency. Simple rules, repeated endlessly, produce light, danger, beauty, fear, and understanding itself. Feynman was deeply allergic to the idea that poetry belongs only to ignorance. He argued that knowing more doesn't flatten experience. It enriches it. A flame seen as electrons dropping between energy levels is not less beautiful than a flame seen as magic. It's more beautiful because now it carries a story. Not a myth, but a real one. One that connects your matchstick to the sun, your fireplace to the birth of stars. Psychologically, this matters because humans hunger for meaning. When we're told the universe is indifferent, we mistake that for emptiness. But indifference is not emptiness, it's neutrality. And out of that neutrality arises complexity so rich that it can produce curiosity, consciousness, and the urge to ask why in the first place. There is something profoundly humbling in realizing that fire does not care about you. And yet, you can understand it. The universe does not explain itself, but it allows itself to be understood. You are not separate from this process. You are made of the same atoms, obeying the same rules, briefly arranged in a way that can reflect on those rules. Feynman never promised comfort. He promised clarity. Understanding fire won't stop it from burning you. Knowledge does not make the universe safer. It makes it more truthful. You still respect the flame, you still step back. But now, layered on top of instinct, there is insight. And that insight changes how you look at everything else. If something as ancient and familiar as fire turns out to be deeper than it appears, what about the rest of your life? What about time, identity, certainty, meaning? Fire becomes a gateway, not a topic, a demonstration that reality is not built to match intuition, but it is built to be understood. In the end, the question, why does fire burn, doesn't just teach physics, it teaches intellectual humility. It teaches patience with complexity. It teaches that understanding is not about arriving at final answers, but about learning how far questions can go. And once you see that, you realize the truth Feynman was pointing toward all along. Understanding doesn't destroy wonder. It reveals how deep wonder really is.